Now let's come to the last topic, that is refraction of light through a glass slab. Refraction of light through a glass slab. Let me first draw the diagram. This is a glass slab. Okay, this is a glass slab. This is glass. Over here there is air and there is also air. So the glass slab is an optically denser medium, air is an optically rarer medium, this one is also an optically rarer medium. So refraction through a rectangular glass slab causes the light to bend first towards the normal. What happens? When a ray of light, it travels and hits this surface. Let's draw a normal over here. After refraction, the ray of light traveling from rarer to denser, it is coming inside the glass. So after refraction, it will bend towards the normal. This one is the angle of refraction. This is angle of incidence. Okay. Again, when the light ray will move away, it will move away from the glass and it will move outside the glass. Glass থেকে যখন বেরিয়ে আবার এয়ারে আসছে, when it moves out of the glass and it go again in the air, over there also another refraction takes place. Let's draw a normal over here. In this case, what happens? The ray of light coming from denser medium going to the rarer medium, it will move away from the normal. This ray of light which comes out, this is called emergent ray. This is another refraction, double refraction taking place. One, when the air is coming entering the glass slab, over there a refraction takes place from air to air, which is a rarer medium, to denser medium. The ray of light, it moves towards the normal. Another refraction takes place when the ray of light, it comes out of the glass slab into the air. Glass slab is a denser medium, air is a rarer medium. The ray of light will move away from the normal. It will move away from the normal, and this is the emergent ray. This is the emergent angle. This one is the emergent ray. Okay, and this is the incident ray. This one is the incident ray. And what happens if there is no glass slab present and the incident ray is allowed to move its own path? That means no glass slab is present, no deviation, no path, there is no change in path taking place. The incident ray could move in its own path. So if there is no glass slab present, what happens? The incident ray should move in this direction. This is the original path. This is the original path of the light. This is the original path of the light ray. But due to the glass slab, this kind of refraction takes place. It undergoes this change of path. It undergoes this bending due to the presence of glass slab. If the glass slab was not present, the incident ray would have moved to its original path. Okay, it has moved to its original path. So there is a shifting of incident ray that takes place. This shifting is called this shifting of original path of incident ray is known as lateral shift. What is called? This is called lateral shift. So what is a lateral shift or lateral displacement? The emergent ray is shifted sideways from the original incident path. The degree of the shift, it depends on the angle of incidence, thickness of the slab and the refractive index of the glass, obviously. And this shifting, that is the shifting of the incident ray from its original path, this is known as lateral shift. And always the angle of incidence is always parallel to angle of emergence. Angle of incidence is parallel to the angle of emergence. That is, incident ray and emergent ray are parallel. Incident ray is parallel to emergent ray. So what happens in case of a rectangular glass slab? The light bends twice. In case of a rectangular glass slab, the light bends twice. Once at the entry or the entry surface, and again in the exit surface. So bending, because glass is an optically denser than air, when the light ray enter, it bends towards the normal, and upon moving out of the glass slab, as it suffers another diffraction, it moves from denser to rarer medium, it moves away from the normal. So due to this refraction, the incident ray path, the original path, gets shifted. That is the lateral shift. This portion is the lateral shift. That is the original, this one is the original path, and this yellow line is the emergent ray. So this is the distance between the original path and the emergent ray is the lateral shift, and always the incident ray will be parallel to the emergent ray. So that ends this portion of refraction of light.